Okay, in this mini lecture, all I'm going to do is work through um, problem number 1 on the homework assignment. And this is the problem where we were working with pickle jars, and we want to have 400 pickles in each jar. So I set up my null hypothesis as mu equals 400. I set up the alternative as mu not equal to 400. Some of you may have set that up as mu is either greater than or less than. I'm not concerned about that at this point, but I did set up my alternative as a two-tail. Our observed mean from a sample of 11 pickle jars was 396 pickles per jar with a standard deviation of 6 and a sample size of 11. So I want you to understand the computation for calculating the observed t-value. So in this instance, with the sample size of 11, we just take our observed mean of 396 pickles, and we subtract the population mean of 400. And then in our denominator, we've got our sample standard deviation divided by the square root of our sample size. You can work through the arithmetic, but my calculation brought us down to an observed t-value of 2.21, actually negative 2.21. Now, since I did a two-tail alternative, my critical t-value with 10 degrees of freedom was 2.23. For those of you who did a one-tail, I think your critical value would have been 1.81. So in my instance, since my critical value of negative 2.21 was not quite as big as the two-tail critical value of 2.23, technically negative 2.23, I failed to reject the null hypothesis. It was close, but I nevertheless failed to reject the null. For those of you who wrote a one-tail alternative, you would have rejected the null hypothesis. So in my instance, since I used a two-tail alternative, I would have concluded that the average number of pickles per pickle jar was about 400. For those of you who used a one-tail alternative, you actually would have rejected the null and concluded that the number of pickles per pickle jar was actually fewer than 400 pickles per jar. I then ask you to increase the sample size from n equals 11 to n equals 16. So here's my computations for that. The only thing that changes in calculating the t-value is that our denominator is our sample standard deviation 6 divided by the square root of 16, our new sample size. So I calculated the observed t-value at negative 2.67. So for those of you who used a two-tail alternative as I did, now you would reject the null hypothesis because the observed t, in an absolute value sense, let me say, the observed t is greater than the critical t. So that would lead you to reject the null. For those of you who wrote a one-tail alternative hypothesis to begin with, it really would not change your decision because with the sample size of 11, you rejected the null hypothesis, and with the sample size of 16, obviously you would reject the null hypothesis as well. So, so coming off of this problem, what I expect you to do is to understand the computation of the observed t-value. I expect you to be able to look up in the t-table and calculate your critical t's, and then compare your observed t to your critical t-values, and then correctly decide whether to reject or fail to reject your null hypothesis. So not a difficult problem, but certainly important in terms of testing what you understand and don't understand at this point. Thanks.